if you're ready.
Yes, sure. Thank you very much.
You're welcome.
Okay. Hi again, guys. Jem. So it's great to see everyone. How was the assignment? Do we have any questions before we continue? Do we have any questions from the last session? Maybe someone needed clarification. We could take 2, 3 minutes to attend to that before we continue. Okay, so no questions. All right. So I guess we can just start. I need to share my screen. Uh, the chat. Okay, yeah. Okay, so just a minute. I'm trying to share my screen. Okay. All right. So hi again, guys. Yeah, my name is Ititi Talk. I'm a software engineer, mostly blockchain dev. These are my handles. Of course, looking forward to connect with every one of us. And yes, so today, from the last session, we actually did do a little hands-on, utilizing the data structures we learned from the previous section, I think, and also getting more familiar with a smart contract and how it really looks like and how to deploy it. Today we'll be just advancing on that. So we'll be looking at some of the best ways to build secure smart contracts, utilizing what we've learned so far. We'll also look at some common vulnerabilities, right? So remember the smart contract is actually very secured, right? So it's your logic, right? It's your logic that makes it vulnerable. So and some other things. We'd also take a look at those things, some best practices, and also some other development tools. Because I noticed in the chat, I think I have more than one person are saying if she must use Foundry. So I think just to be clear, you could use or you can use any programming language of your choice. I'm sorry, not programming language, any development tool of your choice, right? Smart contract development tool of your choice, anyone that you are familiar with, you can actually use it as long as you are able to test your code and then you're able to write secure code. And of course, we'll also be looking at scaffold leaks. So okay, just a little spoiler. So today will be the last day we'll be talking about like mostly smart contracts. We're also going to be talking about smart contract, but moving forward, we are going to be looking at integrating the smart contract into our front-end applications. So we'll also take a look at scaffold leaks and what we are able to do with scaffold leaks. Yep. So, and as always, at any point, if you have a question, I'm not seeing my screen, so you can just maybe I can be checking the chat every now and then, but you can just feel free to unmute and ask your question. Okay. All right, here we go. Vulnerabilities. Okay, so of course, smart contracts we are aware are like the engine room of the blockchain, of course. So of course, smart contracts are susceptible to various vulnerabilities. Here, this means that if for whatsoever reason there is a loophole in your logic, external actors can exploit that. Normally is a norm when writing smart contracts, especially if you are receiving like external inputs, that's parameters from outside your smart contract. It is always best to assume that most of those, or 90% of the time, somebody will be trying to attack your smart contract. So coming from that kind of base, a defensive base, you are able to always be conscious of the logic that you're writing, and of course, um, trying to cover as many possible loophole scenarios as you can. There are so many vulnerabilities over the years. There have also been a lot of hacks when it comes to smart contracts. Of course, we've heard of a couple hacks, like the first hack, which was the DAO on Ethereum, and then the many that followed after it. So, of course, the DAO on Ethereum was a reentrancy attack. There have been other forms of attack. And of course, our awareness of this would allow us write more secured smart contracts. Of course, common vulnerabilities, like I said, include reentrancy attacks. We'll take a look at that. So just an overview. So reentrancy attack is, let's put it this way. We all know that codes are, the logic we write in our codes get executed line after line. So that means if we write 5 lines of code, it's going to execute line 1, line 2, except for whatever reason there is a condition, then maybe it can skip a line or jump to a certain line, right? But normally it's going to execute line 1, line 2, and the rest. So 2 things happen when a smart contract receives it. If there's a fallback function, that's for reentrancy attack right now. So if there's like a fallback function in the smart contract that is sending it to your smart contract, at the point of your smart contract receiving the hit, it's going to trigger a fallback function in the smart contract that is receiving. So for instance, if I wanted to like attack another smart contract, I could literally send it to that smart contract with my attack log, logic, sorry, which basically would be a way to either cause a certain, maybe a denial of service, which would just put the smart contract in a constant loop so it doesn't get executed and it becomes pretty much useless, or it could drain funds from that. So my fallback function will have a logic to execute, and then I send that with it. So once the other smart contract receives my it, my fallback function executes. So this could be anything. So depending on your own logic, which you wrote your own smart contract, if someone sends it to your smart contract with the fallback function, is definitely going to execute. So you need to be able to guide against reentrancy attacks and all of these attacks. There are other ones. For the integer overflow and underflow, it's basically like when we are defining, mostly in integers, when we are defining our size. So if you, for instance, define an integer, say integer 8, and then later on, for whatsoever reason, maybe it needed to be like maybe an integer 12 or 256 or whatsoever. Before Solidity version, I think 0.8.2, that 0.20 rather, it's solved after then. But before then, we used to have this attack where you could send, you could force integers that are larger than what the smart contract is expecting, and then this would cause a crash or a kind of loop in the smart contract or cause some form of attack. But in Solidity compilers from version 0.8.20, I think that issue was also was resolved. We also have access control issues. Of course, basically this has to do with our modifiers, who is able to call our code or who is able to call our functions, who is able to access our state variables, all of that. It falls under access control. So you probably want to have correct or proper access control over your function. Now, these access controls could come in many types. You could have, there's what we call guards. So a guard basically is a simple logic. Mostly you want to use a Boolean, right, or a bool to write a simple logic that translates to true or false, depending on the state of the contract. Or better still, you could use a modifier. So a modifier would also modify that. We'll take a look at that. And then also denial of service attacks. Yes, it's possible in smart contract. In this case, the attacker is not trying to like drain the smart contract of the funds. Probably just trying to make sure that no other person is able to call certain functions on the smart contract. And they can do this by practically, for instance, if you had like an array kind of setting that probably needed maybe people need to like look through your array for certain information. Depending on your logic, right? It's also possible for like an attacker to put that your array or that function in a constant loop with a fallback function. Remember, it's going to send it to you and it's going to call a fallback function that is always going to be in a loop. So that way it will never get executed and then no other person will be able to use that function or that smart contract. So it's always good to guide against all of this. There are more. We could see if we go to solidity by example, right? Well, I think we'll take a look at that in a minute. But if we go to solidity by example, we should be able to see all of that. Awesome. All right. So why are smart contracts vulnerable? Yes, they're vulnerable because they are immutable, meaning that once we deploy it on the blockchain, we cannot change what the bytecodes that exist within the EVM, right? So as long as we cannot change those bytecodes, that means that those set of instructions are going to be there permanently. So it's very, very essential to make sure that whatsoever we are putting on the blockchain, especially on mainnet, is very, very secure. Make sure we always try to test our smart contracts and of course have it audited before we actually push to mainnet. Another reason why another reason why smart contracts are vulnerable is because of course it's most smart contracts or most projects will have their source code open source. That means that both the attackers and your developers that are trying to provide the solution, they have access to the code. So everybody is seeing it. Everybody is taking a look at possible loopholes. So you need to be able to also check for all possible loopholes, right? So as long as the code is public, everybody has access to it. And most times, of course, smart contracts are used, especially in DeFi, right? It involves a lot of transactions. So this tends to attract a lot of bad actors too, to be honest. So in as much as you have very good people writing good smart contracts, you also have very good people writing very good smart contracts to attack whatsoever you are writing, especially when your smart contract holds digital assets or processes digital assets. So it's always very essential to guide against all possible scenarios, right? And of course, smart contracts are, of course, permissionless. This means that they are going to have like complex interactions. Anybody or any other smart contracts can basically interact with your smart contract. So you have to make sure that whatsoever functions that is public or external, you have to make sure that whatsoever logic you're trying to put out there is safe and it will not cause any damage to your users. Yeah. Okay. So common smart contract. Okay, I think I've spoken about this. All right. So the reentrancy attacks, like I said, basically reentrancy attacks occur when an external contract is called before the original contract state changes. So what this means is that, like I was saying, so when you deploy or when you write code, the code gets executed line by line. So at the point where, for instance, an attacker wants to attack your smart contract and possibly maybe drain funds from it, if you do not guide against reentrancy attack, which is making sure that you settle your states before actually doing the transfer, right? So that for whatsoever condition you are putting up, once the reenter or once the attacker re-enters your function, that particular condition should be able to checkmate and make sure it doesn't drain your funds, right? Because if, for instance, let me explain this with Remix. Let's see. This is for okay. So let's go to Remix in a minute and then take a look at this. This is gonna take a minute. Okay. All right. So while that loads, we're gonna come back to that. All right. So another common vulnerability, of course, is the error in our logic. Like I said, so sometimes, of course, for instance, you could make the mistake of maybe you are checking a condition to check if A is equal to B, but for some reason, maybe you put A is not equal to B, right? So this is a smart contract. It's not our normal web 2 where we deploy on a server, and then if we had any issues, we rush and not edit it, right? Once deployed on chain, you can't change that, so that logic would remain. So that's why it's always also essential to have your smart contract, especially for projects that you are deploying to the mainnet, to have your smart contracts audited for all of this, right? As a developer, sometimes it could be an honest mistake. You just maybe didn't see it, or your mind wasn't there. So it's always good to have a third or auditors rather audit your smart contract so that they can point out some of these errors. Let's check the remix. Let's see. Okay, so I think my internet is quite slow right now.
We just have one question about Neha. She asking you if you can explain again the recurrency attacks again. Yes.
Okay, thank you. So, like I was saying, the reentrancy is when you have like your smart contract. Let's say, for instance, you have a smart contract that people can withdraw money from, right? And then you need to always update your state. By updating your state means that the balance of whosoever is sending, let's say A is sending to B, right? So you need to make sure that you update the balance of A, which means you subtract whatsoever amount you are sending to B from A before actually sending it to B, right? Because if you have a reentrancy attack, when the attacker comes back, he's going to meet at the line of code that is actually going to withdraw some amount from the attacker before actually taking money from you, right? Because in the next line of code is going to be your line of code that basically is going to send the funds to B. So if there is an attacker C that enters your code at the point where you are doing that after sending the funds to B. So it's always going to come back to that point and it's always going to send the funds to B. So a fallback function basically is like, there is a condition you can put it and then it acts as a loop. So every time it comes back, it's going to meet that line of code that is going to withdraw money, and then it takes the money, goes back to the fallback function, calls the same withdraw function, and it does that until this is what I mean. Okay, so for some reason, yeah, so we have remix. I'm going to have a simple contract. I'm going to call this I don't know, I'm terrible with names. Why does so right? Okay, so we have our Pragma version, and this is 0. Let's do greater than. So we don't have, okay, 0.8 point, maybe 20 or 30 to match the current Solidity version. On Remix, this is to match this guy, 30. All right. Okay, so this is what I mean. So let's say we have, okay, let's have a simple contract. Let's call this contract A, right? Let's call this contract A, and then contract A is going to be a simple smart contract that, let's say people can deposit. So we have a function to deposit. I'm not going to pass anything. Let them just deposit external, make it payable, and that should work, right? And then we have, let's say function. Okay, let's map this, right? Let's actually map this. So let's have a map one so that we can check the balance of people that are actually depositing. So we map their address. So assign an integer, which will be the amount. And let's call this balances. Right. Okay, so we can map that. So what we can do here is we can see when people deposit, when people deposit, we want to map it and say balances, right? balances of whosoever is sending it, message or sender. We're going to add whatsoever they are sending to that mapping, right? Okay, so whatsoever they are sending, we can add it to this balancing mapping. And then we have a withdraw function, function withdraw, so they can also withdraw. So let's have a function to withdraw. Okay. External payable. And then we should be able to first check that the balance is greater than what they want to withdraw, right? So let's make sure they have certain balances or not. So it's not really important what is important anyway. Let's just check. So let's check that their balance, the balance of message or sender, right, is greater than 0. So if they do not have anything, they shouldn't be able to withdraw anything sufficient or something, sufficient funds. All right, that should work. And then at this point, we're going to use a low-level call. We could use any other call, but I want to use a low-level call to really explain this. So at this point, this is what I mean. So after I will check that this person's balance is greater than 0, at this point, we can do something like to make sure we can first reset this person's balance, right, to be safe. I'm going to explain this later. So we can first reset this, so minus equals their balance, right? The amount that they are going to withdraw, or you can set it to 0 since they're withdrawing everything. So we can set it to 0. And then we can then send this to them. Say, we're going to use a low-level call, success or sent or something, sent is going to be, we're going to send to this message.sender. We're going to call value. Sorry, this is supposed to be curly brackets, not parentheses. So what you can send is you can send the balance, right? So we can send the balance. So say balance is message or sender. This auto, yeah. So and then we can also, we're not sending any data, so we can just send an empty. So this is basically how you send, like, it's with the low-level call. Another way to do this is to do message.sender. You have to make this payable. Sorry. So you can do payable message.sender dots, and then we can either do the transfer or the send. So we can also do this. This should also work. But in this method, right? In this method, there have been some updates that actually checks for reentrancy. It's not 100%, but it sets a gas limit such that if at this point this execution should go through, it's going to refund the remaining gas. So at that point, you cannot call back into the fallback function, but it's not always 100% safe, right? So you can also send it using this way. So I'm just doing this to explain this. So we're going to require send. If not, we are going to pass a message that it failed to send, something like transaction failed or something. So we have a simple smart contract that does this. So at this point, this is where we are going to comment this out. So this is what I was talking about changing states, right? So at this point, before we send out this, we are first going to change the states, right? We're first going to change the states, which is our state variable, to make sure that even if the person comes back, right? So if you call the withdraw function, it's going to go line by line. This is 11. So it's going to first call line 12, check this condition, it passes. We've commented line 13, it's going to come to line 14, and then it's going to do this. So when an attacker wants to attack, what they can do is we can have a contract B that has a fallback function that is going to call into contract A, right? So we can have like, excuse me, say contract B, and this contract B is basically going to, we are going to initialize A because at this point, we're not importing contract A. We don't have access to this. For instance, the contract an attacker will be attacking with probably the bytecode deployed on the blockchain. You don't have access to the source file, for instance. So, but then you remember that any smart contract that is deployed on the blockchain is going to return an address. So this address is the memory location of the byte of that smart contract. So with that knowledge, we can actually use the address of a smart contract that is deployed on the blockchain to interact with that smart contract using our smart contract. So we can do that by, of course, instantiating that smart contract, and then I'm going to make this public. I'm calling the smart contract name here A because our smart contract is I'll call this maybe small a, and then I'll have a constructor that will initialize this. So my constructor is going to take an address, which is the address of the smart contract, in this case A, and then we can initialize that A is equals to A, right? And then at this point, we can call this small a and then probably call, these are external functions. So you should be able to basically call them, right? Okay, so the first thing we can do is to have a function that will attack our smart contract. So how would that function look like? We can do all of this in a fallback, but let's have a function and then a fallback, right? So we have, excuse me, we have our function that is going to call, let's call this attack, something like that, I don't know. So our attack function is basically going to call our fallback function. It's going to send it and then withdraw. So let's call our function. This function simply is going to send it to our contract A rather. So this is payable. And then what we want to do is to send it to our contract. So we can call, I'm having an error here anyway. So we can call our A now, right? So you can say A dot, what do we want to call? Withdraw. So we want to withdraw from A. So we can just simply call A and withdraw. And that's fine, no checks. Why is this here? Expected identifier. Primary expression. Okay, let's see. Okay, so I think we've solved the problem. All right. Okay. So A contract A. Okay. Convertible to type A. We'll initialize A here. So we should be able to Okay, just a minute. Let's see. Okay, that's strange. Anyway, I'll come back to that constructor in a bit. My thought process is in this withdraw function. So I'm going to first also have my fallback function. So my fallback function is going to, yeah, it's warning because the fallback function does not have a receive. So if I had like a receive function like this should solve the problem. But then this would not allow me to really attack, right? So yeah, that should solve the problem. So this will give a little warning like this. Then in my fallback function, I want to call my withdraw function here. So I'm going to say if, for instance, our address A, right? So if, for instance, the smart contract, the balance is greater than zero, what I want to do is I want to keep calling the A dot withdraw function until So I want to keep calling the A dot withdraw function until, let's say, it's greater than zero or one. It could be any condition, for instance, right? So, or zero. So, this is, sorry, variable. Okay. So, anyway, sorry guys, I think this is bringing up a lot. Let me leave this, I'll take it out. So what I'm saying is that at this point in time, we have this fallback function, and what the fallback function is basically doing, right? Because at this point, we are sending it. And then when we send it, remember the next line, we have a fallback function. This is the attacking, contract B is attacking A. So it has a fallback function. So once contract A receives it from contract B. Contract B's fallback function is going to execute, and then it's just going to keep calling into contract A until this condition, right? So here we are saying if the balance of A is greater than one, it should keep calling the withdraw function. So let's assume A has maybe 100 hits. So it's as long as it's greater than one, this fallback function is always going to run. And where it is running is on this line of code because there is no check here, right? So it's always going to come and call the withdraw function, and then the withdraw function checks, okay, the balance of message or sender is greater than zero, fine. Okay, send that the balance to him or to whosoever is calling it. So basically, that's how the withdraw function, the reentrancy stuff attack works. So to stop this, you can either do this. There are many ways to do this, actually. You could do this. You could also have like a guard, like a bool that can return true or false still just before you send these funds out. So, but if we do this, and then this fallback function executes, right? When it comes back to call the withdraw function, it's going to call the first line, and then probably that will check. But then at the second line here, we had already initialized this balance to zero. So there's no way this first line is going to execute. So that way, if there's a fallback function, when it comes at this point, it's not going to execute, right? So your contract would be safe at that point. Would also come and take a look at this. I plan something for around scaffold leaks with this. Hopefully, I hope today we'll have the time to go through that. I hope I answered that question. I don't know what that question. Explain entrance again. Okay, Nehi says thank you. All right, so that's great. So that's what reentrance looks like. And then talking about access control, right? So if we go back to what I was showing here earlier, to for access control, right? So probably if you had this kind of smart contract for access control, you want to have like a kind of modifier. This is basic. I don't see any way we can do the modifier thing here. But basically, you could have a modifier that would actually check certain things, right? So one way could be, let's say, um, you could have like your modifier here that you could call maybe or something like, let's use the modifier first. There are many ways to do this. You could have a modifier, say only clients. That's, I don't know. Just, I mean, I'm referring here to like uh people that use your app, right? So we could say any condition. We have a mapping of balances. So we can say if the balance, right? So if the balance of the message or sender um, is equal to zero, let's say that, then maybe what should happen? No, this is a modifier. So if the balance, or let's use require, could use revert here, should still work. It should be revert and say something like insufficient funds, something like this. And then the rest of the code should continue to exit. So if you have this only client, so somewhere in this withdraw, you could call your only client modifier, right? So you could call your only client modifier here. And then this basically would automatically help check that whosoever is calling this, if their balance is equal to zero, it should revert. And then at this point, maybe you can take this out or leave it if you want, I'm just saying. So I'm talking about access control. So basically, this is one way. There are many ways. Another way could be I could have a Boolean, let's say something like as let's say a bool, something like as withdrawn, something like that. I don't know, as withdrawn, and then I can then every time somebody withdraws, just like we set it here, I can also set. Um, oh, we need to map. We need to map this. This should also be a mapping. So this should be like the mapping of address. Address to bool. Um, yeah, this should be public. Although if we don't specify, the compiler automatically keeps it at public. So if we have this bool, we can basically come here as withdrawn. So just before somebody withdraws, we can set this boolean to true, right? So we can set as withdrawn, and the AI is helping us, which is cool. So we can also do this. So there are many ways we could actually, this is also access control. So at this point, when we're setting it to true, we can check a condition here. And we can say something like require as withdrawn to be false, right? If it's not false, we should tell you that you have already withdrawn, already. Okay, so we can just use the not operator here. Well, what's this? Good and bad of autocomplete. Anyway, so we can also do this. Already withdrawn. This is what I was trying to type. Already withdrawn. So there are many ways we can actually keep our code secured. So we can also, this is of course a Boolean that checks and makes sure that this condition is met. So those are some ways to check for vulnerabilities, access control, denial of service. So of course, denial of service, the attackers are not trying to drain your funds here. What they're trying to do is that they're trying to make sure that no other person is capable of using your smart contract or calling functions in your smart contract. So they keep the state of that function or the state of your smart contract in a continuous loop which will not execute. So and that way the render now they can use it, other people can also use it. Um, okay, so I'm trying to make sure that we keep up with time today. Anyway, so another way is the uninitialized storage pointers here. So if you declare like here they're just talking about variables. So if you declare a variable that you do not initialize, you will notice that your compiler would warn you about such variables. That's because it creates room for people to utilize or for an attacker to utilize that storage for anything, right? Because of course you deployed it, you did not initialize it, so it's just a pointer, a memory pointer that is not doing anything. So it could serve any purpose to anyone. So also, yeah. But an attacker normally would use it to definitely do something that is not going to be nice to your work, right? Okay. Another common vulnerability is front running. So front running here is mostly when like you deposit, when you send transactions, right, to the main pool. We have miners that, of course, are constantly surfing the mempool for transactions. So this outside DeFi, I don't really see this as a vulnerability because it doesn't really matter whose transaction gets mined first on the blockchain if it is not money related, right? So, but then in DeFi, this is very serious because, for instance, before the introduction of flash loans on Uniswap, you could consider a situation where, um, for instance, let's say ETH is cheaper on one exchange, and then maybe there's an arbitrage, a price difference. So it's cheaper on one exchange, so you can easily like buy from one exchange and then you can sell on the other exchange. So this is big money play because most times what people or what the whales would do is that they'll use a lot of funds to buy from these are all decentralized exchanges, right? So they'll use a lot of funds to buy from maybe where it is cheaper. And then what they do is that they set their gas fees very high such that any miner that sees that action would want to mine that transaction immediately to benefit from the high gas fee. So, but what behind the scene, what they're actually doing is that once they're able to mine that transaction, these guys can benefit from arbitrage, buy low, sell high. It might look small, but people made so much money out of it. I think with the Dencon upgrade from Ethereum before Petra, a lot of these things were mitigated, and of course, we are seeing more advances with Petra. And we hope, of course, would have a MEV-free blockchain, but hopefully we'll get there. So another source of, do we have a question? 3, we should start providing names. Yes, please. I'm terrible with names. Uh, okay. All right. So another source of vulnerability is Oracle manipulation. Basically, what this means is that where do you source information that you feed to your smart contract? For instance, if for instance, prices of cryptocurrencies, if you wanted to integrate a price feed into your smart contract that will be able to tell the current price at any point in time, where do you source that? So where you're sourcing it, is it a guaranteed or is it a valid trusted source that is giving you at least very, very close to estimate, or like very, very close to like accurate approximation of the prices, right? So also, it might not necessarily be prices. It could also be like weather feeds, weather information, any kind of information. So you're supplying that to your smart contract. The source, is it trusted? Is the information valid? So because remember, your smart contract is permissionless. So whatsoever you feed it is going to work with that, assuming is going to assume that value or that parameter is valid as long as the conditions are met. So sometimes where we source um, information to feed our smart contract is also very important. We are familiar with Chainlink. Chainlink does a great work of course, aggregating many trusted sources for information, and then we could go there to get that information to pass to our smart contract, of course, for a fee. But then all we're saying in this is that smart contracts are vulnerable if the source of where we're getting information to pass to our smart contract is not trusted, because at the end of the day, the smart contract is always going to compute that information as long as the conditions are met. In these conditions are met, here is maybe like who is sending the information to the smart contract, and all of that. So if you are building like a decentralized exchange, for instance, you probably want to be you want your smart contract to be constantly aware of the price of maybe certain cryptocurrencies that you support on your exchange. And then with this, your smart contract can be able to maybe calculate the fees that they charge for each maybe swap or whatsoever they do on your platform, right? So if this source is not trusted, then of course the information can be manipulated, and then your smart contract would be vulnerable to attack, because an attacker could pass wrong information to your smart contract and force the smart contract to behave in another way, right? So one more, there are many of these. We can see all of these at um, Solidity, by example, should have this. I think I need to find the link. I will. Let me just get that. Let's we think Solidity, by example. Also, the good thing with Solidity, by example, is that it also has this. It has a list of hacks and then some smart contracts, some code you could also try your hands on. I'm gonna wait for that to load. My network is quite slow. Okay, we're here. All right, so if you scroll down to we used to be here, so okay, this is so hacks. You see, it has different kinds of hacks, and then it gives you codes for this, like the reentrancy we talked about a while ago. Self-destruct, yeah, but self-destruct, this doesn't exist, it's deprecated, if I might put it. So here you see Ether depositing. It's basically, okay, gets here. So at this point, you see the attacker here is calling the fallback function, and the fallback function is calling back into the Etherstore smart contract, this Etherstore smart contract that accepts deposits and withdraw, and then you can get balance. So the attacker, yeah, passes the address, and then it calls the attack function. So this attack, right, so it sends money, right? So it calls the deposit. And then after calling the deposit in the Ether store contract, it immediately calls the withdraw function, because there is no logic in the deposit, right? It just accepts money. And then the withdraw function just checks if this user has a balance. And then if the balance is greater than zero, send that person the balance, right? So all this person has to do is just send a little amount of money, and then it's going to check, right? It's going to check one, two, then at this point, it's going to trigger, of course, the fallback function that does only one thing, which is just calls the withdraw function. So it's always going to call the withdraw function until there's no funds to call. And all of this takes gets executed in seconds, right? Because at the end of the day, they are all nodes and they are all computer devices capable of doing more complex computations. So in seconds, an attacker could basically drain your smart contract of all the funds. This is front running. I was just talking about front running a second ago. So you can let me share this link. Sorry, so that I was going to share it. So you can basically just do I share this? Okay. So you can basically go to Solidity by example, try out the different hacks. Of course, they also have solutions and then preventive techniques, right? So they have all of this. So you can also check it out. And yeah. Okay, moving forward. Any questions so far, guys? Anybody, feel free to unmute and ask a question. Any question? Check the chat. Okay. All right. So we continue. All right, great. Okay, so talking about all these vulnerabilities, so what are some of the best practices? Personally, I like to tell people keep it simple. You don't need to write complex logic except you have to. Simple is the best. If it is simple, if it's too simple, an attacker will not be able to attack you, right? Because if you check, go to like Uniswap, for instance, apart from their libraries that are a bit, calculative, their code is pretty much simple. It's pretty much very, very clear. So you can't even find a way to hack it. So simplicity is best, right? Because if you keep your code simple and avoid complexity, most times vulnerabilities or loopholes come from when we are trying to apply complex logic. From my experience, right? Sometimes you can have a solution to something, but as developers, we just have that pride. We want to use the latest technology just to show that we can use it, right? Most times it's nice, but it's not always what we need all the time. So keeping things simple would actually make our smart contract less complex, less bugs, and then of course more secured. And explicitness, of course, it should be able to be human readable and understandable, right? You shouldn't make it pretty much very ambiguous. We shouldn't put too much into one smart contract. By this I mean it's okay to, I'm talking about modularity. It's okay to split your smart contract. In short, in production, most times you hardly find a smart contract that does everything, or a dApp that does everything in one smart contract. You hardly find that. What you would find is multiple smart contracts that act as different subunits, and then you're plugging it into each other. That way, it keeps things simple. It keeps things straight to the point. Also, on my battery. All right, that's the new guys. That should work. Okay. All right. Okay. So sometimes, like I was saying, it's good to keep things, most times, not sometimes, it's good to keep things simple, keep your code clear so that even yourself, when you come back to your code after a while, you should be able to still understand what your code is doing, right? Even without comments, right? It's good to comment your code, but it's always good to comment your code because you always come back to it. But if you keep your code pretty much simple and you're explicit and you're avoiding all the complexity trying to integrate, excuse me, trying to integrate complex tech, right? If you keep it simple, you can come back to your code in a year's time. And by just looking at it, you can know what it does. And then, of course, you can always upgrade or upscale from there. And earlier I talked about staying defensive. Yes, this is also one of the best practices I outlined here because I practice this. I assume, especially when I have a function in my smart contract that is external and is public, I always try to assume the worst because there are so many good developers out there, and then not everybody is good, and then there are a lot of bots also, right? So with the or rather with the advent of AI agents, and then application of these AI agents and the blockchain, the possibility is endless, right? So you have to always come from a defensive side. You have to assume that if your smart contract is expecting an internal or an external parameter, you should always expect that or try to think that, okay, what is the worst that could happen? The worst that could happen is somebody is going to pass in something and try to break your smart contract. So how do you guide against whatsoever they are sending? Okay, Yulia, please go ahead.
Hey, hi, hello, everyone. Just yeah, since we're talking about the best practices and the risks involved in smart contract development, and the other day we had also this conversation with our local community about the audit. Can you maybe comment something on audit, on smart contract audit, like functions, scope, and when can you actually count on audit? Like, yeah.
Yeah, okay. All right, awesome. So audits basically is smart contract auditors basically. They look into what you've written, but they are not looking at it in terms of the solution you are solving. They are looking at it in terms of how secured is your logic. So smart auditing your smart contract is very, very important. Most times you want to do this after you have, of course, a functioning DApp, it's working, you have a few people test it out. Next, you think of security, right? How secure is your logic? What are some of the technical contracts would give you insight into that? I mean, there are many auditing tools also, like Slita and the rest. I've not really tried that Slita, but I know it exists. The last time I did an audit was, I think, for Quantum in 2022. So it's quite a while. So, but then auditing your smart contract basically is like having a third eye or an eagle eye. Take a look at your logic technically. So, is there a place where you are accepting a particular parameter that might be an attacker might use to exploit? So, basically, auditors are looking at your smart contracts for all the loopholes that probably an attacker would want to use to exploit. So, I mean, there's a whole new branch of Web3 that deals with smart contract auditing. If you're interested in that, I'm sure there are some resources to check out, but I would say the best time to actually audit your smart contract is when you have a functioning application, a functioning decentralized application that a few people are testing out and then it's working, and then you are ready for mainnet launch. So before you launch mainnet, you should have it audited. And just to point out, auditing your smart contract is not like 100% sure that it may not be hacked. I mean, from experience, uh, there have been smart contracts that have been hacked, even though they were audited, right? So does it mean that the auditors did a bad work? No. It only means that, I mean, this is a permissionless system. There are uncountable ways people could think of to exploit the smart contracts, right? So the best you can do is, of course, use best practices, use proper modifiers, ensure that what you don't need in your smart contract, you don't put it there. Like, for instance, if you don't need a certain function, don't put it there because somebody is going to use it as long as it exists in your bytecode, right? So yeah, I don't know if that kind of touches on what you're asking, Julia.
Yes, perfect. Quite comprehensive answer. Thank you.
Thank you very much. Okay. So I'm going to take a look. Okay, that's Julia. All right. Okay. So yeah, lastly, of course, I was talking about this staying defensive. Yeah. So I always assume, especially when I'm accepting external parameters. So I mean, these are just guidelines, of course, for you. You could add yours here, but make sure when anything you want to deploy on the blockchain, to always have it audited, especially for production-ready applications. Lastly, is continuous learning. This cannot be overemphasized because the blockchain space is fast evolving. Like every day, there is always like a new technology. There is always some form of abstraction. People are coming up with better ways and simpler ways to get things done. Of course, we are basically abstracting and improving the user experience for users that are using Web3. So at this point, blockchain is always fast evolving. So it's good to always stay. You may not. It's not possible to know everything. You may not be able to know everything, but it's always good to try to have an idea of what is what and what does this do, like in terms of what's the latest technology right now in terms of provided that have made user experience better. So we're talking about things like account abstraction and those other kind of stuff that actually makes interaction with blockchain less user conversive. So it's good to stay not really ahead of the learning curve because the learning curve is quite long. I don't think anybody would be able to learn it all, to be honest. But then maybe there might be few, right? So, but always keep learning, right? Depending on what interests you, right? There's so much technology you could actually explore. So, learning should be continuous, right? So, is somebody saying something? Okay. All right. So with that, we are going to take a look at smart contract development tools. We're already familiar with Remix. Somebody mentioned, I think, Truffle in the other class. I think was it, I'm not sure it's Julia, but somebody mentioned Truffle. So yes, Remix is an IDE, meaning that you can basically write Solidity, deploy from your Remix browser. I think we have not really tried that. So let me take a look. Where's my Remix? This is Remix. Okay. So I'm going to make this a bit large. All right. So to deploy on Remix, right? So let's say we have this simple smart contract. This is going to be addressed. So that solves that problem. So, so let's try to deploy this on Remix. I know not, so it's pretty much straightforward. If we go to the deploy tab here, right? So this is normally where we get our set of Remix loaded addresses or accounts we test it. But to connect to our MetaMask, we use injected provider, right? So there are different versions of Remix virtual machines. This is Prague, Cancun, Menfog, and the rest. But if you want to interact directly with the blockchain, of course, using your MetaMask, we can use our injected provider. So if I do this, it's going to now, you see this address is my MetaMask address. Let's see. This should be, I hope you can see my MetaMask. Sometimes, I don't know, it doesn't come up. Okay, so this is testnet on Leaks Sepolia. So this is Leaks Sepolia. And then this account, this first one, C6F4, C6F180. So yeah, so we have with injected provider, we basically are interacting directly with the blockchain. And then since it is MetaMask, that means it's interacting with the node on our MetaMask, which is specified. In this case, Leak Sepolia, which is, of course, the testnet on Leaks, right? So I can do this. I can deploy YY. I can basically choose which I want to deploy. So let me see contract A. Okay, so I can just deploy this and it's going to pop on my MetaMask, and it's as simple as this to deploy on Leaks using your MetaMask. So you just confirm your transaction, and then once that is completed, it will return. So this is the contract address. So we just have the deposit and then the withdraw and as withdraw. So if I copy this and check in the Block Scout Explorer, Sepolia this time, sorry, Sepolia Block Scout. So if I check there, we should be able to see that that particular this address, we should be able to see that we have a contract deployment on the Leaks testnet with contract name A, although it's not verified, so we shouldn't be able to see. So I'll come back to this. So yeah, so you can do that with Remix. Hardhat is another is an advanced development environment. Of course, this allows us to write Solidity code, but then we use JavaScript or TypeScript to either deploy it or interact with it after we deploy it. Of course, we also have Truffle, and of course Brownie. These are not, I don't know about your region, but they are not really popular in my region. I mean, it used to be popular until I think Hada changed the game, and then Foundry just took it to another level. But basically, all of these are smart contract development tools. So depending on the one that you are most familiar with, right? Because at the end of the day, they all do the same thing, right? Which is they allow you to build, they allow you to deploy, and then they allow you to interact with your smart contract. So whichever one is you are most comfortable with, please go ahead and continue using that, of course. And then we have Scaffold Leaks. So just like we have Remix, let me check this. Okay, so this is not it. This is the contract address 52. Let me confirm that. 5. This is what I'm looking at here. 542 E7F. So this is 542 E7F. All right. So we can see this is actually the Leaks testnet explorer. And if we check transactions, we should see that we have a contract deployment some minutes ago, if not seconds, no, not minutes, seconds, minutes. Anyway, this takes a while, it's taking a while. Okay, so we also have Scaffold Leaks. Like I said, Scaffold Leaks is actually a framework. It's a fork of Scaffold It, which is basically a boilerplate, a Next.js boilerplate that has been configured so that it allows us to write smart contracts in Solidity. And then, of course, the framework basically takes care of most of the heavy lifting for us, meaning that it gives us a UI which we can customize, a UI we can use to interact with our deploy smart contract. We can also write our smart contract directly in the framework, and then we can deploy one or multiple smart contracts, all using the Scaffold Leaks framework. So it is a Next.js framework, which means it's something we are already familiar with, right? So behind the hood, it is powered on the smart contract side. Scaffold Leaks is powered by Hardhat by default, but you can also configure it to use Foundry if you want it. But by default means that you are going to be interacting more with TypeScript after writing, of course, your code in Solidity. So we'll take a look at that. And then this is our contract 4 minutes ago, contract creation. We have not verified it. We should have seen the name. So to get started with scaffolds, I'll take any question before I continue. Question. It will be cool to have a tool to actually attack your smart contract and check the volume, like Bob said. I think first you need to write out, Sonia, I think first you need to write out your smart contract. And then, I mean, it could be like fun, right? You write a smart contract and ask your friend to attack your smart contract. I mean, to be nice, there's always a way to do that. But I am not aware of any tool that does this. I know Slitter does editing and then some analytics on your smart contract. But I'm not sure there is actually a Bob Suits equivalent for Web3. Hey, maybe you could build it for us, right? Yeah. Okay, yeah, Donia, yes, Donia, you mentioned truffle. Yeah, yes, you can use it if you're comfortable with it. I always thought Bahati Jacko. I always thought so too. I always thought truffle was deprecated, but I mean, if you can use it and if you are using it, please keep using it. Okay, so scaffolding. So I'm going to share this. This is it. Let me share this link. This link is also available in the it's also available in the resources in the classroom. Okay. So it gets a little dark here, and for some reason, I don't know, but let's keep going. All right. So with that link, first thing we need to do is to spin up our Scaffoldix project, and then it's pretty much straightforward. It explains a little here that is a fork, but this is basically a quick start. So you need to clone this repo. Let's do that. Let's do that. We'll clone the repo and then terrible with names. I'm gonna call this SS. I'm gonna see it to SS. Open this in breakouts to the page. Okay, so we have a new project. So like I said, first thing we're going to clone the repo, right? So yeah. My terminal is taking a while. I don't know why it's doing that. Okay. So just to be sure I'm in the right place, I'm going to increase this so we can see it. All right. So I'm going to paste, clone the repo rather. So we're going to clone the repo, we're going to install dependencies, and then we are good to go. So it's a boilerplate, meaning that it comes pre-configured. You could basically do a lot. Like for instance, you could select a network, you could have a local blockchain node, just like Anvil or Hard nodes to work with locally, and then you can also deploy directly to the blockchain. So there are some commands here, like to spin up your local node. You can run yarn chain to deploy, yarn deploy, and then of course to spin up the front end. Of course, yarn start will spin up a Next.js project with the front end, so we could visualize our smart contract. Let's see how that goes. Okay, so we have our Scaffoldix project here. I'm going to CD into the project, and then I'm going to do yarn add because I want to install the dependencies, right? So I just have to yarn install rather, not add. Yarn install will install all dependencies. So while that is happening, I'm just going to go through. This is going to take some time. So while that is happening, should bring this down. Okay. I want to go through some commands that we have. Normally, the default command is yarn. And then, of course, we on Scaffold you could do yarn account, yarn chain. So yarn account basically is going to, if you have, there are two ways you could do this for the yarn account. So you could either put your private key, like get the private key for the account you want to use to work with, and put it in the .env file. And then it will basically is configured to be able to pick that up and sign transactions on your behalf without you being or without you specifying your private key and all of that. And then if you don't want to do that, you can just do a yarn generate, and it's going to generate a brand new wallet for you, and then of course give you your private key. Not really give you, but save your private key in a .env file that you can basically use. Yarn chain would spin up a local blockchain node, like I said, just like Foundry with Anvil or Hardhat with Hardhat node. You could also fork the mainnet, the deploy with deploy, you could verify, you could do all of this. So, and then the yarn starts here will basically spin up the front end side. All of this is in the packages here. And then you see we have the default is Next.js, like, sorry, the default smart contract environment that, excuse me, that Scaffold Leaks offers is actually Hardhat, but you could configure it to Foundry if you want. Okay. And then you see everything happens in the packages folder where you have, this is the front end, this is the smart contracts, right? So no need of separating your work. You have both of them in one place. Okay, it's getting a bit, I don't know, my light is not quite bright. So I'll just put this off. Okay. I think this should work better. All right. Okay, so we have the front end part, and then of course we have the smart contract part here. And then in the front end, right now, we won't find many things. We should have, we have the types here, we have the ABI types, and then we don't have anything in our ABI types. So this basically is configured, right? So this would generate, every time we deploy a smart contract, it's going to generate our ABI type, and then it's going to save it. I think somewhere in these services, no, this is called Connect. It's going to save it in, yeah, the chain.ts, right? This is for our network. I think that auto generates. Let's see. Once this is done, we should be able to, once we finish installing all dependencies, so I think we should be able to get go. It's complaining about VM, a library for interacting with the blockchain, just like Ethers, right? And then for the smart contract side, of course, we have the deploy script. Now there are some default things that came with it. So in the contract, we have 3 smart contracts, normal Solidity smart contract, and then we have the deploy script. So each of these scripts basically is a configuration. So this means that if we wanted to add our smart contract, after adding your smart contract here, you also need to add a deploy script, right? So this is what the deploy script looks like. It basically tells a way to be able to get your smart contract. Like this deploy script here is getting your contracts, of course, from the contracts folder, and then basically it's deploying it. And I think it's initializing something here. Yeah, it calls a method. It console logs a method, right? So it deploys and console logs, and then returns a tag. We'll talk about these tags later. And then if you come to your contract, you should see that this contract name is your contract, right? So this is just a normal smart contract that does what? There's an owner, You can set greeting, you can withdraw. I think that's pretty much it. But then you have a script that basically tells Scaffoldix, when you use the yarn deploy, what to do and where to find your contract. So each of them have their own scripts. They're pretty much straightforward. Just it's a normal deployment script you write with JavaScript. You use the deploy the contract name, buy me a coffee, and then I think you deploy the contract here, and then this is a method that was called, right? Okay, and then there is the tag. So we'll talk about this tag. Like I said, I'm waiting for this guy to install. Okay, and then we also have scripts. So you could write other scripts. Like, of course, like I said, all of this is configured, right? It's a boilerplate that makes writing smart contracts and interacting with it very easy and straightforward for us. And then we have the hard config file that basically processes how we connect to the blockchain. Like you see here, we have Alchemy, or this is like a fallback default Alchemy API key, which I doubt would work. And then you could have this is a Solidity version. The default network is the local host, which if we don't specify anything, it's going to fall back to if we spin up the local blockchain on our device, and then we don't specify a network, it's going to fall back to the local host, that's the local blockchain on our device. And I wanted to show something here. All of these have API keys. They may not really connect, but the ones without API keys would definitely connect. And of course, luckily, Lex Sepolia, of course, is one of those that would connect because it doesn't require an API key. So we can basically connect to the Lex testnets without worrying about that. This is really taking some time, but it has to run its course. And then I'm just going through some things like this is what I was saying. So at this point, if you have your private key that you wanted to use to sign, maybe deploy the smart contracts as the owner and the rest, you can just put it here or create. This is an example. So you create a .env file and you specify the environment precisely as deployer private key, and then you pass in your private key, and then Scaffoldix would be able to pick up that signer and then deploy and send transactions using that signer. So it's all configured for ease, so we don't really have to do much. And then when we deploy our smart contract, I think it's you have in the front end, I think there will be like a deployed folder because we have contracts. Yeah. So in this deployed contracts, not this one, this one, this one. So in these deployed contracts, once we deploy any smart contract, the Scaffoldix automatically populates this file with the address of the smart contract and the API of the application binary interface, the API of the smart contract. So we can basically, we don't need to worry about, I'm just showing us where they are. We might not really need them because we can just interact from our command line without worrying about this, but it's always good to know where they are in case you needed to make edits. So the deploy contract in the front end folder would have the ABI and of course the address of any smart contract that we deploy here. This is taking a while. I hope this works out soon. And then besides that, every other thing is pre-configured. There are many components to choose from. If, for instance, you wanted to maybe, of course, edit your front end or edit your page, you want to make it look better, nicer. There are a lot of components to choose from. Of course, there are hooks. Yeah, this is what I'm looking for. Yeah, So there are a lot of hooks you could actually use in case, and all of this does a particular task. Like for instance, they use scaffold contracts, would basically grab the contracts for you to be able to read and write to. So you don't even need to worry about all of this, but I'm just showing us um, how it was configured, basically. So it's a boilerplate, more like a bootstrap. It gives you a front end, and then it also allows you to interact with your smart contract or write and interact with your smart contracts all from one particular project folder. So I'll take any questions while I'm waiting for uh, this to load up. I have 4 messages in the chat. Scaffold deprecated. Are there any scaffold kits that use Foundry or actually you choose during setup? Okay, so Yulia, like I said, by default, Scaffold comes with Next.js. I mean, Scaffold is a fork of Scaffold it. There are many other ones. There is, I think there is also Scaffold OP for building on the superchain. So, but it's a fork of Scaffold it basically. So by default, it comes configured with hard hats, but you can reconfigure it precisely to use Foundry if you wanted to. But I think when using Scaffoldix, since it allows you to interact with JavaScript or TypeScript precisely, and then you are definitely going to use that interaction in your front end, it would be nice to also keep it maybe in TypeScript, right? Or rather in using hard hat, because Foundry would mean that you write and test in, of course, you can also deploy in Solidity, right? But it's cool. And whichever one you prefer, yes. Several methods are configured on scaffolding. Is it possible to deploy on several chains at once? No. It's not possible to deploy on several chains at once, but it's possible to deploy on several chains. So let me go back to that. This is the front end, and then this is, let me go to the hard hat config file. Right, so these are all the available chains that you can basically deploy. Sepolia, Mainnet, Arbitrum, Sepolia. So basically, you can work with any of these chains, but then you realize that some of these chains require your provider API keys, so you can configure that in your .environment. Like for instance, this is an Alchemy API key. So if you pass that in a .env file, Scaffoldix will pick that up and supply it as this parameter. Where is it? Yeah, your provider API parameter. So you can basically pick that and provide it there. I hope that answered that question. Okay, so this is quite slow. So sorry. I just want to allow this to run. Okay, let's see. I saw a chat. Is the difference between Scaffoldix and Scaffold eating contract type and hooks? No. So Scaffold it is the full package, right? It's pretty heavy. It's heavier than, by heavy I mean in size. So it does a lot more because it kind of like takes care of building on Ethereum. But Scaffoldix is a fork, meaning is a lightweight of Scaffold it. So what we do with Scaffoldix is it gives us a kind of like a lighter version without like everything that comes with Scaffold it, because Scaffold it does a lot. I mean, if you when you clone like a Scaffold it repo, it takes quite some time to be able to not configure, but to clone, install all dependencies, because is the full package, so it takes a lot of size and a lot of data. But Scaffold Leaks is a light version that allows you to do pretty much all the necessary, or yeah, pretty much all the necessary stuff, using a lighter version, and then with focus on building on leaks here, but then with options to build on other chains also. Julia, I hope I answered that question. Okay, so this is really taking a while. I hope it doesn't bite into our time that much. But if anybody has a question, please feel free to unmute and ask your question. We are almost there. I need this to come true. Okay, so while that is coming up, where was I? So this is hard, and then, of course, the front and the back end all in one package. Another question? Let's see. What was the answer to this briefly? Sorry, I lost connection. Okay, yeah, so Sienna, you cannot build on all chains at once, but you can build on several chains, yes. And then to know, like I was explaining here, these are the available chains that you can actually, but you can specify any chain that is not here. You can literally add it, and then using your tags, you should be able to access it. But these are the available chains that come by default. Hard hat here refers to the local node, and then we have Ethereum, Mainnet, Sepolia, Arbitrum. There are quite a number of them, right? Even Polygon, ZK, Gnosis Chain, Base, but some of them require provider API keys, which you can supply in your hard hats. And these are a .env example. So basically you want to create like a .env file and then pass in like precisely as it is Alchemy API key. And then Scaffold Leaks will be able to pick that up and supply that in your wherever it's needed. Like for instance here, just like your deployer private key. So if you have your private key in the .env file, yeah, deployer private key, so automatically Scaffold Leaks will be able to pick that up and supply it wherever it's needed. For instance, in getting your account on this chain, for instance. But we would be deploying on the leaks, Sepolia leaks should be somewhere there. Okay. So we'll be specifying leak Sepolia. And then, of course, this is the URL with the private key. When we spin up a local node, a hard local node, it picks the first address, right? And uses that as the private key. So we don't even need to supply private keys at any point in time. Okay, so I think this guy is almost true. It doesn't really take much time like this. I think it's actually because of my internet. My internet contributes to this also. Yeah. So, but we are almost there. Yeah. And then let's go back to the slides. Okay, Scaffold Leaks. All right. Okay, so Scaffold Leaks, yes. So Scaffold Leaks is a framework, like I've said. It's a fork of, yeah, the Scaffold OP, but Scaffold OP is also like a fork of Scaffold It. So, yeah. And then it offers several features to be able to, for developers to build and deploy with ease, of course, on the Leaks chain and other available chains, right? So it supports burner wallets, local faucet functionalities, which means that it allows developers to be able to build and test their applications without even spending like maybe their test tokens and the rest, right? So, yeah. And then this belt, not found. I was going to must be there because it's blue. They still I'm not done yet with this. Okay, so fetch starts and then okay, so yep. here we go. We have our package running. I've talked on, I think, pretty much what we need, where the contracts are, and the rest. So to start to know if this is actually working, we're going to try to spin up, like I said. So you can do a yarn chain, like I said. All of this is in the package.json. So these are the commands you can run. So yarn account, yarn chain, yarn fork. So if we do like in yarn account, for instance, we have not supplied any private key. So this should return, it should tell us that we do not have any account. So yarn account should tell us we do not have any account because in the .env, we do not have a private key, right? So okay, and then what's the response? Taking away. Okay. Oh, it had to compile our smart contract first. That's okay. So you can see here, we do not have anything. So for this to work, we're going to run 3 terminals. I'm going to use this one for interaction, and then I'm going to make this bigger. Okay, so I'm going to use this for interaction, and then I'm going to create a new one. Could be PowerShell, doesn't matter. And then in the new one, I'm going to spin up a local node first and foremost. Where are we? Okay. So yarn chain would spin up a local node for us. So this should give us like in Foundry or Remix, it should give us a set of wallets with some available it for, of course, testing purposes. Okay, so this gives us all of this. And then we don't have to worry about getting the private key and passing the private key because when we want to deploy, Scaffold Leaks is going to pick this first account and then pick this private key and use it for us. Okay, so we have that. So we can also spin up the front end with yarn stats. It should be Scaffold. Yeah. So yarn stats should spin up the front end. It's a Next.js project, so we are familiar with Next.js, similar to React, but it's more about convention, not configuration. Okay, so it will take another few seconds to spin up. And then this is my, let's see, where is the original tab I was on? Okay, so this is the tab I was on. And then let's take a look at the contract. This is the contract. They buy me a coffee. I don't know what this is. This small MC. This contracts. Okay, so this is a charity. Okay. Anyway, so it's another contract, and then this is the simple greeter contract. So of course we can do this both ways, right? So to deploy we already compiled it. So to deploy a smart contract, okay, 2 messages. What was the answer? Okay, let's see. Is there a difference between contract? Super, thank you. So one can deploy chain by chain if one wanted to. Yes, of course. You could specify the chain also. So if we did like let's make sure our our blockchain is running and our front end is ready. So let's take a look at the front end. Let's see, local is 3000. So this should spin up local is 3000. Let's take a look at the backend. It's compiling. All right, great. And then we have our blockchain running, which is also great. And then we have 3 contracts. So we can, if you wanted to specify a particular contract, right, we could do a yarn deploy. and then we could specify using tags, and then we want to specify the name of the smart contract. In this case, okay, let me get the name. What's the name? The name is your contract. So we can specify that. And then we have your contract. And then this will deploy only your contract, right? It's going to deploy it on the local blockchain. And then Scaffoldix is going to take care of the rest. It's going to take the ABI, put it in the proper folder so that the front end can be able to read it. And then if you don't want to like specify a tag, you want to deploy everything. Remember, all of this is locally, right? If you wanted to deploy this on Leaks, for instance, on Leaks Sepolia, we can specify with the network flag, and then we pass in the name as it is on the configuration, which is this name, Leaks Sepolia. So we pass in Leaks Sepolia, but make sure that you have your private key in the environment variable, because at this point, this will not work because Scaffoldix there's no private key, it doesn't know where to fetch it. But if we do this on the local node, inshallah, let's deploy everything. So let's just do any deploy. And then you see we didn't specify network or private key, it has been abstracted away. And then it's going to deploy all three contracts. Remember, this is running on the local blockchain on our device. So at this point, you see it deployed my contract, your contract, the buy me a coffee contract, the third one, with all of this. So now this is the interesting part. If we go to the front end, hopefully our front end should be up by now. Where is our front end? Okay, so I can't find the front end. This is serious. Okay, so for some reason I cannot find what's going on here. Oh, the browser was closed for some reason. Didn't shut down. Okay. So I don't know why that happened. Let's spin up the local host again. Okay, I'm seeing remember to sign attendance. Okay. All right. Anyway, so I'm waiting for the front end to come up. This is our front end. Okay. So now we have the front end. This is what the front end looks like. We are having an error here. I don't know why that's happening. So the good thing is that behind the hood, of course, Scaffoldix is going to update once it's deployed. If we go to debug contracts, it's going to automatically connect our deployed contracts with our ABI, and then we should have an interface. Yeah, this kind of interface, right? So something like this, like Remix. So we have the buy me a coffee here, and then we have the VDN contract and the contract. So you see that we only deployed it, and then behind the hood, Scaffoldix was able to get the ABI connected to, of course, this front end, which this is a page, right? So we can basically modify this page. So let's see, this is for testnet. This is locally, not testnet. We can connect our wallets. Let me import this first. I want to import, we can do it two ways. So I'm going to first import this private key, the first one. Oh, yeah, 0. So I'm going to import this into my MetaMask so that I can use it on the local blockchain. This takes a while. For some reason, my internet is quite terrible right now. Okay, so this is taking a while. Come on, come on, come on. Okay. All right. So while I'm waiting for my MetaMask to come up, what more am I supposed to do? Well, I've deployed the smart contract. Two messages. MetaMask is the worst. I'm still looking for alternative. Uh, sometimes, right? Sometimes it might just be internet problem. Like I think what I'm experiencing right now might just be internet trouble. Then it's not even coming up anymore. Okay, so but I need the MetaMask to pop up. And then anyway, once I was going to import that, I don't know why it's giving me a hard time. Or I can't connect because my MetaMask is still working its magic. Okay. This is crazy. Anyway, I'm not gonna let this deter us. We'll come back to this. Hopefully by then it should have solved itself. 35. Open the browser. It works, right? Okay. So okay, let's see. I'm gonna close the browser now. And then I'm going to open the browser again. Okay. Close and open browser. It really sucks, to be honest, Sonia. It really sucks, and it's really, really annoying right now. I think I'm gonna close this again completely, and then I'm going to try to open it all over again. I think I still have one. This is the slides. Let's see if it does the same thing, and then if it does the same thing, I'm going to this is crazy. Anyway, let me try it. I have a Chrome browser. I love browser. I've been using it for a long time. So, but I also have a Chrome browser that has MetaMask. Let's hope it doesn't behave like the other one. Uh, okay, so this other browser is smiling at me right now, which is cool. Amazing. So I can spin up my local host here. And then for my browser, yep. Okay, so now I can import, where is it? First, I can import this private key to my, so it has already connected, wonderful. So this is Leaks, no, I want to switch network to hard but I have not yet imported hard. Let me cancel that. Sorry. I need to import the wallet so I can have the direct link to. I need to do this add wallets, private key, then import, connect. Okay, let's Sequoia. This is the one that I imported. Okay. Now it has some faucet on Lake Sequoia already. Let's switch to hard hats. Okay, so I have my hard hat wallets on my interface now. And then remember we deployed our smart contract, so we should be able to see it here. So this is the front end that Scaffold Lakes gives you. So you could have your smart contracts. You could just only worry about writing your smart contract in the hard hat file, in the contract folder, and then you create a deploy script for it. That's just the only two things you need to do. And then Scaffold Lakes will pick all of that and then give you this interface with, of course, the functions in your smart contract to interact with. So could basically set, for instance, set this greeting, say hi, and some value in which then we should send this. It should give us like a normal user feel of popping up your MetaMask and signing transactions. But all of this is done on the local node, right? So yeah, so now we have a certain greeting and then we have some stuff going on. But then the thing is that all of this is on our local node running locally here on this node. So, but then what if we want to do something directly on, all right, so we have all of this, where is, I'm looking for it. So, okay, but then we have contract call and the rest and the rest. So, but we don't want to only do this. We want to deploy on the blockchain, right? So all of this was done on the testnet. So to deploy on the blockchain directly, we can keep our front end. So we can keep our front end running. This is the local blockchain. I'm going to stop this just to show we are running on the blockchain directly. Okay, so we don't have the local node running. We want to do things on the blockchain directly. So that means we have to, of course, redeploy our smart contract and the rest and the rest. So there are two ways, like I said. We can either come and create a private a .env file from this .env.example, and then we can put our private key there, and then Scaffold Lakes would do the rest for us. But I'm just going to do yarn generate, and then it's going to create a new wallet, put the private key in a .environment file, and then I will just send some ETH to that address, and I should be able to, of course, yeah. So now you see it has created a new wallet. This is the address. Let me copy this. I will need it. Let me export this just in case I copy something else. So this is my address. Just in case. This is a PowerShell. Okay, it's not gonna work, which is fine. But this is my address, and then you see it has created a .env file. I'm going to show you guys this. Doesn't matter. I'm not going to use this. So this is a .env file, right? So this is the private key, and then it has the deployer stuff, deployer private key. So this is how your .env would look like, and then Scaffold Lakes will pick up the rest for you. So now the problem now is that we can't really, let me, excuse me, let me copy this address again. We can't really deploy now because we do not have any ETH on this address or on this wallet to basically make any call for us. Let's see. So now we have deployment on localhost, and then you can see our ABI has been generated. All of this was auto-generated, right? So we have the contract address and then the ABI. So if we deploy a new contract, it modifies this without us having to really worry about it. But that's by the way. What I was going to do is want to deploy to an actual blockchain. And then we have our address there. But then if we do Payan account, now we should be able to see all the supported accounts and how much we have. So, but then I know we don't have any value in this one. So I'm going to send some ETH to REITs. And then also, if you look at the front end side of things here, under contracts, we have deployed contracts. This is what I was saying. I'll come back to this later. So even on the front end side, you see that we have the ABI and the contract address already configured, courtesy of Carfolix. So this is how your front end is able to interact with the blockchain, basically, by passing in the address of the bytecode. Remember, the address is the location of your bytecode on the blockchain. And then the ABI is a human readable interface of the bytecode that is deployed on the blockchain. So basically, this ABI is how a combination of this ABI and your wallet address, or your contract address rather, your contract address and the ABI, using any Web3 library or provider. The provider in this case is a node. It could be Leaks, it could be Ethereum. You'll be able to interact with, of course, the application that you have deployed on the blockchain, but you need your address and then your ABI. And then, of course, Scaffold is automating this for us automatically. All right, so having said that, I'm trying to, so now we can see some accounts now. Before it was saying we do not have any account, but now we have our public address here. And then all the network that requested or that demanded API keys, you see, we cannot connect to them. We cannot connect to them. But the ones without API keys, we can connect to them. But then if you supply API keys like an Alchemy API key, of course, you'll be able to access every other chain here. But this is what we need. We need Leak Sepolia. So I'm going to go to my, I need my MetaMask now. I need to send some ETH to this address. Hopefully this is going to work now or not. Let me see. Hopefully I have some ETH here. I need to change this back. This is a newly created account, and then this is my account on. Okay, so I don't have any ETH here. And then this is imported and it won't work. Okay, so, and I'm still having this challenge. This is crazy. I really need some ETH Sepolia. I'm going to close this and try to open it again. So right now, my MetaMask on my Brave browser is not my best friend right now. So I need to send some Sepolia ETH. Okay, so we have a class going on. Would anybody here close your browser? Close your browser. Sorry, we'll look recording. Okay, no problem. Great. Okay, so guys, I think I need some Sepolia ETH, which my MetaMask is refusing me access right now. It's crazy, right? Let's see. Wow. Okay, so I closed it and it worked. So we are back. So we are really back. Okay. So I'm just going to send. These are all test token, guys. So I'm going to send some test token to this address, the newly created address. Send. I'm going to send 0.001. That should be enough. Okay. And then, of course, the transaction time on leaks is 2 seconds. So once this is confirmed, we are good to go. Should be able to get that in 2 seconds. Activity sent. Okay. So we'll come back to our project to see, just to be sure. I'm going to check the account again. Just to be sure that the phone is there, right? Before we start deploying. We need to deploy this to the Leaks Sepolia testnets, and then we'll see how we interact with it on the front end. And then while this is coming up on the front end side, I need to anyway, I'm going to use this other guy so that I can be able to pay for gas fees. There is no it on the other Chrome address or on the other Chrome distance, sorry. So now, because we are now going to use the leaks testnets, this is going to give us error, but it's fine. So now we have received our funds. So this is the fund I sent. So it's fine. We can continue. So it's pretty much straightforward. We want to deploy or yarn deploy. We're still going to deploy everything. So yarn deploy, but this time we're going to pass in a network flag, and then we're going to say leaks Sepolia, and that's it. Pretty much straightforward, I think, compared to when we are interacting directly with either hard hat or sorry, when we're interacting directly with Foundry, we had to specify passing a lot of flags and all of that. But this is pretty much straightforward, right? So we deployed multiple contracts. So this is the contract it deployed. So now if I'm going to check this first one, I'm going to check it on the Block Scout, Sepolia, Block Scout, Sepolia. Just to make sure that, and then I need to change, this is Leaks Sepolia, so it has updated our contract definition, meaning that if we go to debug, we should be able to see all our deployed here. So this is actually on the Leaks testnet right now, not on the local node, which was running before, right? So if we do anything now, like for instance, interact with this contract, say hi again, and then send some value, say, let's say 100 way. I hope I have up to that. But this should be able to pay for gas fee anyway. And then let's see. Okay, so that went through, and then we're going to check the address of the contract. So this is the address of the contract. This is the address of the first contract, your contract, which I just interacted with just now. So this is actually on the Leaks blockchain, super fast, without without complexity in terms of deploying, in terms of interacting with it. So this is pretty much straightforward. 6 questions. I will send you some of my okay. How do we get these test tokens? Okay, so you need it on Leaks to be able to pay for gas fee on the Leaks chain. You can do this, of course, by there are links in the resources, but the fastest way, if you already have like Sepolia it, you can visit bridge.leaks.com. You could bridge your testnet it from Sepolia to the Leaks chain. Also, I missed that attendance.
Sorry, I just want to remind the people that they need to sign their attendance in the Google Classroom. So now it's 8 and 9, but normally it's until 8. It's already unavailable. Okay, so no worries. I will manage it this Okay. So it's still it's not available. I will see it.
Okay, thank you very much. All right. So I think for me, I think that's pretty much it. So we have deployed this on the Leaks testnet, and then if we come here, of course, using Scaffold Leaks, we have an interface to interact with, of course. So this is, if I take my address here and check, I should be able to see that I sent this message on the Leaks testnet. I call the set greeting function. And if I do something else, like call it again, for instance, add another 0 to it, I should see that I called it again. So basically, using Scaffold Leaks, we abstracted away the complexity of deploying using the command line, of course, like we saw from the last class with Foundry. So this is pretty much straightforward, and then you can spin up a front end like this. That could help you, interact while working on your smart contract. You could check it out. And then since this is a Next.js project, it means that you can completely customize this front end to something you want. Yeah. So I think that's it from me. Let's check the slides. This is where we are. And then, yeah, any questions? Of course, there is an assignment where we have to identify the vulnerability in this smart contract, this vulnerable piggy bank contract. And then once you identify it, try to fix it, and then have probably another contract that will try to maybe attack this smart contract. Just something fun, and then submit, of course, push your code to GitHub, and then deploy it. Actually, when you deploy it, submit the address of your deployed contract or the Block Scout URL in your README file that you push to the blog or that you push to GitHub. Yeah. Yeah. So I think that's it from me. Do you have any questions? Okay, no questions. Okay. All right. So Celine, I think that's it for me. Thank you very much.